So I want to talk for a second what makes our ammonoids different from our nautiloids. Because as we see, it should be pretty clear that they're both similar, right? We have organisms that have a coiled shell, and we've got a squid-like structure of an animal that's in there, and the animal has a siphon, it's pushing water that way, which means the animal's moving this way. So in general, the animal itself is the same. However, there's a fundamental difference between our ammonoids and our nautiloids. As we saw with our nautiloids have a very smooth shell. And our nautiloids are small. They don't get very big. Now, on the other hand, our ammonoids, they have patterns on the outside. And their patterns are the suture marks. So if you remember, right, when we look at a nautiloid, if we look, or at an ammonoid in general, if we look on the inside, if we could cut their shell open, we see that we have chambers. Now, what happens is as the organism gets bigger, it makes a new chamber, and that's what it lives off of. So in the nautiloids, there is an expression of the suture marks, and it's just color. However, color does not fossilize well, so we don't see it. In the ammonoid, however, we can see the suture marks on the outside. And as you learned, right, there are 3 types. So our first type, okay, that we can see are the goniat, right? And the goniat have this very simple zigzag pattern. The third type is the ceratite. And the ceratite physically have hills and valleys. So if you were to feel this, right, so here's a hill and a valley. So if you were to feel this, if you were to feel it and put your fingers over it, it would feel bumpy. And the third type is the ammonoid itself, and the ammonoid, as you see, has a really complex suture pattern, right, as you saw in that picture in the previous slide. Now, why would these ammonoids have a complex suture pattern? All right, why? What's the need for this? Well, the nautiloids, let's say here's our water column. Okay, so here we got some fish, right? Our nautiloids are staying shallow. They're staying up here. Now, obviously the ammonoids are eating something similar to what the nautiloids are eating, but they're in competition. So the ammonoids need to go deeper. And in order to go deeper, obviously pressure increases. Right? There's much more pressure the deeper you go. So in order for the organisms, these ammonoids, to survive down here, right, without those chambers collapsing in due to the pressure, they create these really complex suture patterns. Okay, and what that does is that sends the stress, and it kind of sends it out across the suture pattern, so that way the chamber doesn't collapse. Now, the other thing that these ammonoids are doing is they're also getting huge. When I say huge, I've seen some ammonoids that are about 10 feet tall, right, 10 feet across. They get really, really big. So the bigger you are and the more complex suture pattern you have, the deeper you can dive. So that's fundamentally how our nautiloids are different than our ammonoids.